Hi, I'm Nick. I'm a lead instructor for Nebula Academy, and today we're going to be talking about drones and how we can code to them and how they can be used in an educational setting.
All right, so we're, this is part of our series every week. We're going to be bringing in new tech, and Nick's going to be joining me. So we're going to be talking about drones, and really what's cool about this, Nick, and you've got a lot of experience with these. You've been using these for the last few years, right?
Yeah.
And what I want to emphasize for those listening is that this is not just for educators. This is great for school, and if schools can embrace this, we've done this. These are indoor drones; they're not designed for outside. This setting that you're seeing here on the floor here that we have set up is easy to do in a classroom environment or in the gym. Right, the gym's a great place to do it.
Or at home if you want to educate your kids as a parent.
Yep, parents. This is a great way to really get some fun and education together, blended. If you're teaching, you're doing any kind of learning at home with your kids. And also for summer school programs. If you're out there and you're not for profit and you're running some kind of STEM or STEAM summer program, we do these kind of with our summer programs all the time, and they're really beneficial, again, because it's getting kids excited about coding. and so sometimes coding can be pretty dry to learn, right, Nick?
Yeah. But with the drones, as soon as the students hook up with the drag and drop coding and they get it flying, even if it's not a complex mission, their faces light up. And you'll have lots of different instances with that. Like, after the first couple missions, we'll tell them how to use the flip. And then the student's his faces light up again.
Flipping is a cool thing.
Flipping, so the drone will literally flip in the air.
Yeah.
What else is great? When they have some sort of logic and the drone is doing, autonomous flying, and it's choosing, like, okay, is the situation odd or even? Am I going left or right? Am I flipping or am I turning?
Yeah.
And then at the same time, there's a lot of, so that's all of the sort of highs that the students might get. But on the other end, they're also learning that they have to understand the technology they're working with and understand how it works to get the most out of it, right?
And spatial awareness, right?
Yes. So that's the other thing. It always frustrates me. At school, you only learn spatial awareness when you're playing sports, right, traditionally. But nowadays, you can have the drone and you're going to tell it to fly 50 inches, 100 inches, 10 centimeters, whatever it may be. And the students will start to understand what those distances are, which is something that you never got in the classroom.
In traditional classroom, right? Yeah. So it's kind of a way to kind of take and think out of the box, literally, with your students, and thinking about how do you get them excited about computer science skills and the importance of all of these skills that we learn. It's all problem solving, and so no matter whether they go into computer science or become coders or not, there's value here from an education perspective and a learning experience. And it's just about energizing them. It's tough today. We know as educators how hard it is to get people engaged, and these are a super way to get engaged. We've done this with 100 students in a room and 25 drones flying at the same time in a big space. And our teachers that were there said, I can't believe I've never seen my kids so engaged in learning before. Mm-hmm. So it's always a great impact.
And then on top of that, it really hones in on computational thinking. So just to dive into the, not all students have to become coders, but they definitely have to have an understanding of how it works overall and how it's gonna fit in with their career, right? If you're in marketing and you're building marketing materials, what does the development team need from you to be able to develop the website properly, right? And then, computational thinking is all about breaking down a larger problem into smaller subsets and breaking those subsets into even smaller subsets. And that's really like the great thing about the younger generations learning how to code. They're learning how to teach themselves and tackle large problems on a small bit by bit.
Yeah.
Right?
So let's, we're obviously showing some drag and drop coding here for this, right? Because this drone, we'll talk a little bit about scaffolding, right? Mm-hmm. So from a investment in tech too, this is the other thing too. Schools will say, well, I spend that money, and this drone's about $100, right, to buy this thing. And the batteries, they're very simple, right? The batteries are here, just rechargeable, so you can repurpose them. We always suggest at least 3 batteries per drone, mm-hmm. And extra blades because they can break, and bumpers here. They're real safe. They're, again, indoor only. They're not designed to be outside, but they are designed for education. They have a lot of great algorithms for safety. So let's talk a little bit about that, Nick.
Yeah, so I'll get into the safety in a moment. The first thing is they're super durable. I've seen these The worst situation I saw was just like a perfect corner on the wall. Drone managed to get in, the corner comes in like right in the center, and the blades broke. Everything else is totally fine. You just pop off the broken blades, put the new ones on, no cost. The blades come with the drone. So until you've gone through a couple hundred, then eventually you might have to buy your own blades, which are cents. Safety-wise, let's talk about, a normal drone. You don't want to get your finger in the blades because it will cause a lot of damage. With these things, you can put your fingers in there and it will hurt, but there's no blood. I've never seen any blood, and I'm usually the one sticking my fingers in. So, I'd be very happy putting my fingers in here. Also, we've got sensors on the bottom, which add consistency to what the drone does. So, unlike a lot of other cheap tech, and I'll put this on the cheaper side, the drone is going to do what you tell it to do, or within a margin of error, but a much closer margin of error than something else that thinks it's moving 20 inches. This will measure that it's going 20 inches, as well as doing the calculated applied force, right? Other safety features, so the bumpers protect both students and the drone itself. And then the way it's developed. So we get to code to the drone using drag and drop coding, but underneath the hood, there's some logic and thinking the drone's doing it in itself. And really what it all is all of the drone's defaults are to slowly land, right? And by doing that, it's created a much safer and more useful product. So for example, you think using these, like we're doing it on the ground right now, but in a classroom, you don't have to fly the drones from the ground. You can have them take off right from your desk, because you can catch the drone in your hand. You can have it land in your hand, which is very nice.
And kids love that.
Yeah, exactly. And you can prevent the drones from going down on top of laptops. But again, if they're going on an edge, they'll stabilize, that sort of thing. I think that's most of the safety features. So you've got, if it's doing something wrong, like it's going into the wall, it will understand, okay, I'm just going to try and land, stuck to the roof, try and land. Too much air resistance, could be AC inside, but usually it's an open window or something like that. It's just going to try and land. Yeah, it's built to protect itself and the students. I think that's really what the goal is.
All right, cool. So let's talk a little bit about the drag and drop. So we've got this drag and drop coding here that we're using with the drone blocks, right?
Yeah.
That's the company that we work with. And the drones are, you can buy them on Amazon, or you can actually buy kits for educator purposes. You can buy these from Drone Blocks as well. Or you can buy them from Nebula Academy. And we actually provide the training and everything else to get you ready to use these and all that stuff too. So what we wanted to show you today is just a kind of example of how this computational thinking and physical computing can look and how exciting it can be. But we also want to stress that this is, and we'll have future sessions on this stuff and get more into the concepts of it, but we want to also stress the scaffolding with the drag and drop coding. Now again, introducing students to code, you can introduce drag and drop coding at any age group. Now everybody out there, like some developers, software developers might have a different opinion of that. They might say, oh, don't ever introduce them to drag and drop coding. They should go right into hardcore coding. But what we find in our experiences, even with our adult classes, is that introducing this stuff with the drag and drop after they've even learned some coding, they love it. And then now you can actually take them to the next level, because technology technologies like this have the scaffolding. They have what are the different platforms you can code in here?
So you can do JavaScript, Python, Node-RED, which is a JavaScript program, and drag and drop. Those are the primary ones that I'm thinking of.
Yeah. So what age group do you think these are? What age group would you recommend that we?
Well, we use these with our student programs at We Connect the Dots, and then we also do them with our cohorts at Nebula Academy. So our software engineers, people going into the workforce, use these, and they always tell us that they get good learning experience from it. My recommendation would be freshman year of high school. So what would that be, 13?
Yeah, 13 to 18,
I think
that age group for the young adults.
Exactly.
And if you're a parent and you want to do this with a younger child, certainly can, right? Just supervision. This is not something you're going to leave them on their own, to kind of explore and play with, because there's definitely some supervision required. But as you get into the 13 years olds and they're working in teams, it's a great learning experience.
And it's perfect because in high school you've got your engineering teams and whatnot, and you could ease in from having this simple drone that's got its own software development kit or SDK, and drag and drop coding. You could bring that in freshman year and then scale up. Like the year after, you're going to be coding, and then the year after that, maybe you instead of using JavaScript, you use Python, and
Yep.
then eventually you can get to more complex stuff like using out of the box like AI, like facial recognition, and
Yeah, with a camera and that, right?
yeah. So if you're interested in the drone itself and how far you can go, you could definitely head to YouTube and look up, Tello drone, and there'll be some pretty cool stuff.
Yeah, so it does definitely have some great, from an ROI or return on investment for you buying something like this from hardware, it definitely has the ability to kind of grow with the students as they progress in their learning experience for coding.
Yeah,
So
and
fantastic.
like a drone like this one, I don't know if this one is specifically, but our oldest drones are 4
4 or 5 years old.
Yeah, 4 or 5 years
old.
old.
They've been used by hundreds of kids.
Yeah.
And they're still going.
Yeah, we've had one drone that we had to troubleshoot,
Yeah.
but that's it. And the
Okay.
troubleshooting's easy.
Yeah. All right. So what we're going to do now is we're going to, you've got some code here that you're going to show them. So maybe describe the code and what we're going to do.
Yeah. So if we can just look at the loops here, the noodles. Yeah. What we've done is we've taped 2 pool noodles together and attached them. They're about 50 inches apart right now, or
So
each
tape
arch
measure
is 50.
required for doing this.
Yeah. And make the students measure it out. So what the drone does is it will fly from the starting point through each noodle, and then it'll go forwards, and then through again, forwards, and then back through this way, right? And what I've got here is instead of just telling the drone fly forwards, fly left, fly forwards, fly right, fly forwards, fly left, I did something a little more scalable, right? So no matter how many arches there are, the drone can, I can just change the number, like one number, and the drone will fly through all of them because it's got a loop, and that loop is telling the drone if it's odd, let's fly to the right. If it's even, let's fly to the left. And we've just got a count keeping track of whether it's odd or even. So yeah, if we take a look at the code, the drone is going to take off. It naturally takes off to about 60 inches. So we're telling it immediately to fly down 20, which gets it to about 30 to 40 inches away from the ground. We're then setting our horizontal length or number that we're going to fly. And it's not neither left nor right in this instance. It also doesn't have a distance. It's just the number 30. It's a variable set to 30. We then have our repeat block, which is a loop. In this instance, we're flying through 3 arches. So we have the number 3 there. And then at the beginning of every single loop or every single iteration, we're going to set horizontal to the negative of itself. So if it's at 30, we're now going to go to negative 30. If it's at negative 30 multiplied by negative 1, it's now going to go back to 30, right? After we set that variable, we're going to fly forwards 50 inches, and then we're going to fly to the side whatever our horizontal value is, right? So initially, we're going to be flying forward. We're going to be flying to the right 30 inches, and then we'll fly forwards again, and then we'll fly left 30 inches, and then we'll fly forwards again, and we'll fly right 30 inches. That's our 3 arches, right? So now if I were to describe it more in depth, it's going to be begin the loop, set the variable, fly forwards, fly to the right, flip the variable to being negative, fly forwards again, fly left, flip the variable again, fly forwards, fly right, and then we end the loop, and then we're going to land.
All right, awesome. Now, so can you quickly just maybe show, from the scaffolding perspective, how they might see the JavaScript in here so they can see how that code that they just built with drag and drop?
From here, you may want to bring your students to the next level. And the best way of doing that is by familiarizing the students with the code as you go. So we can actually click on the hashes and then say show mission code, and we can see what the actual JavaScript would look like for this bit of code. So you can see it's pretty simple. It looks very different, but it's pretty simple. And the nice thing about 2 of the most popular languages right now, JavaScript and Python, is they pretty much read like English. So I'll read through this, and this is JavaScript, and we'll see we'll see the similarities, right? So we're declaring a variable called horizontal. We are then executing the takeoff function. We are then executing the fly down function, flying down 20 inches. We are then setting a number to our horizontal variable, which is 30. And then we've got this, doesn't read like English part. So for var count equals 0, count is less than 3, and we increase, plus is increased by 1. So what that actually is our iteration or our loop. This is super common to see in any object-oriented language like JavaScript. And what we're going to do inside each loop is say horizontal is equal to itself multiplied by -1, fly forwards 50 inches, and then we've got our fly xyz function, which takes in 4 variables. You know, what's our x direction, our y direction, our z direction, and are we flying in inches or centimeters? And then we go through that 3 times because our count is saying up until we reach 3. And then we exit the loop, and we are going to execute the land function.
Awesome. So that's really showing so educators and students how they can take that drag and drop and then experience what that might look like in JavaScript.
Yeah, absolutely.
Yeah.
And then there's the next place you would go from here would be introducing the students to the SDK. So you can go into the GitHub for the drones, and there's the software development kit, which will tell you all of the functions that you're seeing on the right and which the students can pick through them. The same way in drag and drop, we've got all the options on the left, and you can pick through them.
So thanks for joining us. We look forward to having you join us again next week and to learn more about how tech can enhance your learning experiences in your classroom and your not-for-profit organization summer program, or for moms and dads at home looking to really enhance what their students are learning and maybe complement what their schools are doing today. So it's especially if you have a child who's super energized by this stuff and their schools maybe don't offer this and you want to expose them to it, these are great ways at a low cost to really support them. So thank you for listening. Please visit our website at nebulaacademy.com, or if you really are interested in joining some of our student programs, visit weconnectthedots.org, make a donation, help us do more for kids who need this and need the opportunity to get exposure. And again, thanks for joining us. Have a great day.